Hi! Here we will solve a math challenge question of numbers, that is, Fermat's little theorem. This channel explores mathematics and provides guidance on solving math problems. The question is, if p is a prime number, the a to the power of p minus a is divisible by p for any positive integer a. How do we solve this question? There are two cases for integer a. Case 1 is that integer a is divisible by p. Then, a equals q times p. I to the power of p minus a equals qp to the power of p minus qp. It equals p times q to the p times p to the p minus 1 minus q. Thus, it is divisible by p. Case 2, if integer a is not divisible by p, we can use the integers a, 2a, 3a, and so on, p minus 1 times a, which are not divisible by p. Then, a equals q1 times p, plus or 1. 2a equals q2 times p, plus or 2. 3a equals q3 times p, plus or 3. And so on, ma equals qm times p, plus or m. Na equals qn times p, plus or n. p minus 1 times a equals qp minus 1 times p, plus or p minus 1. q1, q2, q3, and so on, qp minus 1, are the quotients. R1, R2, R3, and so on, Rp minus 1, are the remainders. Where m, n are equal to or greater than 1, and m, n equal to or less than, p minus 1. Rm, Rn are equal to or greater than 1, and Rm, Rn equal to or less than, p minus 1. Regarding the remainders, R1, R2, R3, and so on, Rp minus 1. M times a equals qm times p, plus or m. N times a equals qn times p, plus or n. If m is not equal to n, assume the remainders, Rm equals Rn, we have m minus n, times a, equals qm minus qn, times p. We already know, the absolute value of m minus n, is less than p. It denotes that a is divisible by p. But, we have the earlier assumption that a is not divisible by p. This result contradicts the earlier assumption. Therefore, if m is not equal to n, Rm is not equal to Rn. Thus, the remainders, R1, R2, R3, and so on, Rp minus 1, are the numbers 1, 2, 3, and so on, p minus 1. These remainders are different from one another. That is, R1, R2, R3, and so on, Rp minus 1, are the numbers 1, 2, 3, and so on, p minus 1, with sequence order arrangement. Next, we can multiply the numbers a, 2a, 3a, and so on, p minus 1, times a, together. Then, the product of these numbers equals 1 times 2, times 3, and so on, times p minus 1, times a to the power of p minus 1. It equals m times p, plus 1 times 2, times 3, and so on, times p minus 1. Where m is an integer. Then, 1 times 2, times 3, and so on, times p minus 1, times a to the p minus 1, minus 1, equals m times p. Therefore, it shows that a to the power of p minus 1, minus 1, is divisible by p. And then, a to the power of p minus a is divisible by p. The question of Fermat's little theorem is solved here. Thanks for watching this video. If you like this video, please click the thumb up button, the subscriber bell, share icon, and subscribe to this channel. Thank you.